Hello everyone, welcome to this video to learn how to find out the drain current by using Shockley equation. So first I will start with the first problem. So in this problem, they specified that the drain characteristic of JFET as shown in the figure 4.5, it specified we need to read the IDSS from this graph and later VP from the graph. Using Shockley equation, check the value of ID for VGS is equals to 1 minus 1 and VGS is equals to minus 2. So by observing the graph, we can able to find some parameters. What are the parameter we can find out? First parameter we can find out IDSS. So here in the graph, it is specified that IDSS value is 8 milliamps. Whereas VP, it is same as VGS is equals to minus 4. At VGS is equals to minus 4, the drain current will become constant. So these are the data I can obtain from the graph. So once we have the data, then we'll go for finding the value of ID at VGS is equals to minus 1. So here, these are the data I obtained from the graph. IDSS is equals to 8 milliamps and VP is equals to minus 4. And we know that the Shockley equation for finding the drain current is given by ID is equals to IDSS into 1 minus VGS divided by VP whole square. Now I have the value VGS is equals to minus 1 and VP value is minus 4. Then I have a value of IDS is equals to 8 milliamps. Now I'm going to substitute those value to this equation to find out the ID value. So once I will take the consideration at VGS is equals to minus 1, what will be the ID value? Now, if I substitute the IDSS value is 8 milliamps and VGSS value is minus 1, that is substituted in the equation, then VP value is minus 4, that value also substituted. Once I simplify this mathematical expression, so now here what happens? Minus and minus get cancelled. And we left with 1 by 4. 1 minus 1 by 4 is nothing but 3 by 4. So then we have 8 multiplied by 3 by 4 whole square. If I simplify, I'll get 9 by 2. So this 9 by 2 is nothing but 4.5 milliamps. It indicates that at VGS is equals to minus 1, we had a drain current of JFET is 4.5 milliamps. Now I have to find out the drain current when VGS is equals to minus 2. Now if I take a consideration at VGS is equals to minus 2, what will be the ID value? So I'll go ahead with using the same Shockley equation. So I'll substitute the values. So here IDSS value is 8 and VGS value is minus 2, that will be substituted. And we had VP value is 4. Now if I simplify this mathematical expression, I'll get a value of 2 milliamps. Now, from this problem, we found out the drain current of a FET when VGS is equals to minus 1 and VGS is equals to minus 2. Now, I'll proceed with the another problem based on using the Shockley equation only. So, another problem is something called as JFET. Here, in this problem, for JFET, with in this problem, so now I'll proceed with the another problem. Now I'll proceed with the another problem for the JFET only. So for JFET, IDSS is equals to 6 milliamps and VP is equals to minus 4.5 volts. We need to determine the ID value at VGS is equals to minus 2 and minus 4. And similarly, I need to find out VGS and at one particular ID value. ID is equals to 3 and 5.5 milliamps. First, I will proceed with the first part, that is finding the ID with the known VGS. Now, I know Shockley equation, ID is equals to IDSS into 1 minus VGS divided by VP whole square. We know the IDS value is 6 milliamps, and VGS value, I'm considering VGS is -2 at this case, and we have VP value is -4.5. If I substitute these values to this equation, so then I will get 6 into 1 minus -2 divided by -4.5 whole square. That if I simplify this mathematical expression, I will get an answer of 1.85 milliamps. Now I'll take another case like VGS is equals to -4. Then what will be the ID value? So when VGS value is -4, here where VGS is there in this equation, that value is substituted is -4, and remaining parameters like IDS as well as VP will be remain same. So if I simplify this mathematical expression, I'll get an answer of 0.074 milliamps. Now I completed with the finding a ID value when VGS is provided. Now what is the next parameter I need to find out? The next parameter I need to find out the VGS when ID value is provided. So here also I will go with using the same Shockley equation only. So here ID value is given is 3 milliamps, and IDSS value is provided is the 6 milliamps, that is substituted. And after that VGS, we know that VGS value is to be calculated, and we have the VP value is -4.5. So if I consider this equation, so here what happens, if I simplify this equation, so I'll get an expression like 1 plus 0.222 VGS whole square is equals to 0.5. Now if I further simplify this, how I can further simplify? Take a square root on both sides, then we'll get 1.0022 VGS is equals to plus or minus 0.707. Now I need to find out the VGS only. So that's why I'm considering 0.22 VGS is equals to, if I take this 1 to the right side, that will become minus. So that's why it will become minus 1.707. So after that, we'll go for finding the, what is a VGS? VGS will get minus 1.32. This is a one value. Another value is minus 7.73. Why? Because here it is a plus or minus 0.707 is there. If I consider minus, then it is minus 1.707. If it is plus, then what happens? 1 minus 1 plus 0.707. That's why you'll get minus 0.293. So this is a way we can find out the VGS when I know the ID, IDS and VP value. So there is another scenario, it is specified in this problem. I need to calculate the VGS only if ID value is 5.5 milliamps. I'll go ahead with the same this equation only to calculate VGS. Here IDS value is 5.5 milli and IDSS value is 6, and this is a mathematical expression I'll get once I substitute this value only. If I further simplify, so I'll get this equation, that is 0.917 is equals to 1 plus 0.222 VG square, and if I take a square root on both sides, I will get 1 plus 0.222 VGS is equals to plus or minus 0.957. Once I go with the finding the VGS, now here 0.222 VGS is equals to minus 0.043. This is a one value when considered as a positive. If I considered minus 0.95 and this one, if I take it to right side, it will become minus. That is nothing but minus 1.957. So we have a VGS value. Once we go for calculating the VGS value, if I divide this value with this, then I'll get a final answer of VGS is equals to 0.194. Thank you for listening this video.